Hello everyone, my name is Alana Benitez, and this is our presentation for Programming Assignment 5. In this project, we wrote a program that simulates how two-page replacement algorithms with FIFO and LRU work in memory management. The program reads a list of page references from a file and compares how each algorithm behaves using a fixed number of page frames. We count the number of page faults and observe how the memory changes over time.
So the program accepts two command line arguments, the name of the input and the number of pages of page frames. For example, running the command dot slash page replace my file dot text 3 will simulate memory management with 3 frames using the page reference in the file. In our test file, the reference string looks like this: 701203 042303 03212 01701. The number of frames must be between 1 and 10. If it's not, the program will show an error and stop.
So now let's take a look at how FIFO or first in, first out is implemented. So we used a pointer called next to replace that cycles through the memory slots. I'm just gonna go ahead and into the code right here. Yeah, next to replace is right here. And basically each time that there's a page fault, we replace the page that's been in memory the longest, the one at the pointer. Then we move the pointer forward in a circular way. It's simple, but it doesn't consider how often or how recently a page was used.
LRU, or least recently used, is a bit smarter. It keep tracks of when each page was last accessed using the used array. When there is a page fault, we replace the page that has been used with the longest time. This usually results in fewer page faults because it tries to keep the most active pages in memory. We update the timestamps every time a page is used, so we know which one is being evicted.
So now here's what the output looks like when we run the program. We compile it using gcc-o page replace, and then with the C extension place replace, and then ran dot slash page replace my file text 3. The output shows this: FIFO 15 pages faults. Final stage, final state of memory, FIFO 701, all ALRU 12 page faults, and then final state of memory 107.
And yeah, basically a big challenge we ran into was making sure the memory initialization and page comparisons were correct, especially for LRU. At first, we didn't handle empty frames properly, and that caused incorrect evictions. We fixed this by initializing all memory frames to -1 and checking for that value before applying the replacement logic. No, wait. Yeah, everything. Okay, can we start over? I'm
Yeah,
sorry.
what happened?
I think my phone's like not updated enough like my computer is.
If we could redo it, if you want, you could close Ocelot and reopen it again and run it one more time to make sure everything looks good.
I don't think like the way I ran this code is right because it doesn't say FIFO 15 page faults. It doesn't say that. This is weird.
What does the output say?
Like it says something different. It goes straight to the final state of memory and then it says 11 page faults.
So we're missing, so it says 14 page faults when you say 15.
And then
I don't
yeah,
know
it
why
says
it's
12
different.
page faults. Yeah, and then
I don't think the memory, like the order matters. I do think like what it obtains.
Pager eplace, pager eplace.c. It's that my Zoom menu's like in the way, so I can't see my own text.
Look, let me tell this recording. Hold
How do
up.
I take this off?